Hello everyone, welcome to this channel. I'm Payman Hasari, and in this video I'm going to implement logistic regression in KNIME using Titanic dataset. The dataset describes the survival status of individual passengers on the Titanic. The link to the dataset is in the description. The problem is a binary classification, and that's why we use logistic regression. Logistic regression is a supervised machine learning algorithm used primarily for binary classification tasks. Let's get started by opening a new empty canvas. And give it a name. And finish. Let's bring the dataset into the canvas. Because the dataset is a CSV file, I use a CSV reader. And let's configure this one. And here is where you need to locate where your dataset is. Click on Browse and locate where your dataset is. Open. And here you can take a look at the dataset and click OK. And then execute it. And finally, you can take a look at the data by right-click and use the file table. Here is the dataset. We see that we have 891 rows or data points with 12 features or columns. And here survived is a target variable that we use. And because it is numeric, we have to convert it to the categorical variables. And features like passenger ID, names, ticket, and cabin are unique to each person and are not informative in prediction. So we remove them from the dataset. Other features like sex and embark are categorical, and we should convert them to numeric because machine learning algorithms do not understand categorical variables. And also there are some missing values in other columns that we have to handle them. And these are some pre-processing steps that we're going to do. And after doing this pre-processing steps, we can build our logistic regression model. So let's close this one. Next, I'm going to remove those uninformative features using a node called column filter. Bring the node here, connect it with this one, and configure this. So I'm going to exclude those features: passenger ID, names, ticket, and cabin. Click OK, execute it. And let's take a look at the result. And now we have only 8 columns. So next, I'm going to convert the target variable survived from numeric to categorical variables. And in order to do that, I use a node called number to string. Bring the node here, connect it with this one, and configure this. And I'm going to exclude everything except survived, which is a numerical features that I want to convert it to a categorical variables. Click OK and execute this. Next step, I'm going to split the data set into the training set and test set. And in order to do that, I use a node called table partitioning. Bring the table partitioner here. Connect it with this one. And configure this. So the first partition that I'm going to use, I choose relative. So I use 80% of the data for training and 20% for testing. And the sampling strategy, because it is a classification, I prefer to use stratified, but you can use random or linear or first rows. So I choose stratified. If you choose the stratified, you need to choose the target variable here as well. So the group column is survived, and I use a fixed random seed to make sure that the training set and test set stays the same no matter how many times I run the algorithm. Click OK. The next step is to convert the categorical variables to numeric. And in order to do that, I use a node called one-to-many. Bring the one-to-many node here. And connect these two nodes together and configure this. And here, the survive is our target variable. We don't need to convert that one. Sex and embark should be converted to numerical. Click OK and execute this one. Let's take a look at the result. So we have the sex as original column, which has only two category, female and male, and two column, male and female, has been created. And if the original row is female, then female is 1, the male is 0. Otherwise, if it is male, male column is 1 and female is 0. And as you see here, this sex column is extra. We have to get rid of this one. And the sum of male and female is always 1. So in order not to have collinearity in the data set, we have to remove one of these two columns. So either male or female should be removed from the data set, and we will do that a bit later. The situation is the same for embark. There are C, S, and Q variables here. 3 column C, S, and Q has been created. And the sum of these 3 columns for each row is equal 1. And again, we need to remove one of these columns. Close this one. The next step is to take care of missing values. And in order to do that, I use a node called missing values. Bring missing value operator here. Connected with this one. And configure this. If the variable is categorical, I'm going to replace it with the most frequent value. If the missing value is numeric, I'm going to replace it with the average formula. Click OK and execute. Let's take a look at the result. And as you see now, there is no missing value. There is no question mark here anymore. Close this one. Now we have done our pre-processing steps. The next step is to build logistic regression model. And I'm going to use a node called Logistic Regression Learner. Bring it here. And connect it with this node. Figure this. The target column is our survived variable. And reference, because it is 0 and 1, I'm going to choose 1. And this is where you need to remove those features that were extra. I'm going to remove sex because it is categorical. The same for embark. And I can remove male or female. Let's remove female. And from S, C, and Q, I can remove one of them. Let's remove Q. And click OK. And This is our model. Let's execute. And next, I'm going to apply this model on the training set and calculate the performance of the model. So let's, in order to do that, I use an operator called Logistic Regression Predictor. Bring it here. This one has two input. One is the model that comes from the Logistic Regression model. And the second one is dataset. I'm going to use this data, which is the training dataset. And this one has nothing to configure. Just leave it as it is and execute it. But what it does, if we take a look at the result, it will give us a prediction column, which is this one, whether it is 0 or 1. And in order to calculate the performance, use a node called a scorer. Bring the scorer node here. Connect it with this one and configure this. The first column is our target variable, which is the survived. The second column is prediction of survive, and you can choose the sorting strategy. It doesn't matter which one to choose, and click OK. Run and open views. And this is the results. It gives me accuracy of almost 76% on the training set. And this is our confusion matrix. And this is the performance of the model on the training set. Next, I need to calculate the performance of the model on the test set as well. Now, we're going to calculate the performance of the model on the test data. And in order to do that, all of those pre-processing steps that we did on the training data should be applied on the test data. We start from this one, which we convert categorical variables to numerical. And in order to do that, I use a node called PMML transformation apply. Bring it here. It has two inputs. One is the model that comes from this node. And the data should come from the second partition of the table partitioner, which is the test data. And we have nothing to configure here. Just simply execute. And let's take a look at the result. So it applies the same transformation of categorical variables sex and embarked. And we have the same columns that we had for the training set. Next, I'm going to take care of missing values on the test data, and I use a node called missing value apply. So bring the missing value apply node here. Again, it has two inputs. One is the model that comes from missing value. And the next one is the data from this node. And again, configuration has nothing to do because it applies the same technique that applied for the training set and applied on the test data as well. So execute it. And finally, we need to apply the logistic regression on the test data. And again, we use logistic regression predictor. Bring this one here. And again, it has two inputs. One is the model that comes from the logistic regression learner. And the data comes from this part. And again, it has nothing to configure, just execute it and calculate the performance using a scorer. And can bring the score node here and connect it with this one and configure. The configuration is exactly the same as the previous one. So the first column is survived, the second column is prediction of survived, and I'm going to choose lexical sorting strategy and execute and open views. And now we have almost 75% accuracy on the test data, and this is the confusion matrix for the test data as well. Now, in order to improve the performance of the model on both training set and test set, what you can do is to come back here and change some hyperparameter values that you have. For example, you can change the way that you partition the data, the way that you convert the categorical variables to numerical, how to handle missing values, or change some hyperparameter of the logistic regression model. And here, for example, you can even take a look at the advanced setting and change some of these hyperparameter here. And you need to find a combination of all of those hyperparameter to improve the performance of the model.